Hello everyone, welcome to my YouTube channel. So in this video, we will be discussing about the interview question, and if you will observe, this question has been very widely asked in a lot of interviews. So I will attach this question link in the description of this video. It says that you need to find out the duplicate number in a given list. Now you have to understand that the values which are available in a list is in a sequence from 1 to n plus 1. So basically you will be having in total n plus 1 number of values available in a list, in which there will be a sequence of elements from 1 to n, and one element will be repeated. Okay, so let's say I will provide 1, 2, 3, 3, 4, or it can be unsorted as well. But the important thing which you have to take care of here is that we have elements from sequence 1 to 4, and there is one element which is repeated, which is 3. So what I want as an output is 3. Okay, this is what I'm looking for. So you can try to read out the problem statement going to the LeetCode platform and check it out. This video is a recording of my paid course where I have discussed this particular important question which is very widely asked in interviews. Now if I'll ask you this question, let's say in an interview will ask from you, the very first approach which I think everyone can tell to the interviewer is that we can take the help of a dictionary based data structure, in which we can try to use a key value pair where the key is a unique number that we have and the value is the frequency of that number, right? Am I saying it correctly? This is the approach which I think it is coming in your head as well, right? Those who are watching me live. So basically what you are saying to me that what you will do, you will try to take the unique elements. For example, in our question, in our use case, you will take 1, 2, 3 and 4. And the count of 1 is 1, the count of 2 is 1, the count of 3 is 2, and the count of 4 is 1. So at any point of time, wherever the value is more than 1, that will be the repeated element which you can print it out, right? So that is the thing which seems to be correct, right? It's a correct approach. Even if you will run this particular approach on the LeetCode platform, you will find out that the test cases are passing properly. But there is one statement which you will study in the platform itself. They have mentioned that try to use a approach where the space complexity is constant. Means here if I'll say that what is the time and the space complexity of this approach which you have given me, you will clearly observe it's a linear, right? When I'm saying time, you are scanning the entire hash table or dictionary which you have created, and then you are trying to scan which element is having a frequency more than 1. It's a linear time. Then when I'm talking about a space complexity, you are using an external data structure apart from the given list which is available. And again, that is also of big O of n based space complexity, right? You are trying to, store almost n elements in your keys as a keys, right? And correspond to that, you are trying to store the values, which is the frequency of every element. Now, the question is how we can optimize this particular thing. Almost, I believe, if I'll say a ratio, 98% of the audience already aware about the first approach, which I have talked about, and I think you can easily implement that as well. The second approach is something which is interesting, where we want the space complexity as a constant space complexity, and that's where the concept of Floyd's cycle detection algorithm will come into picture. In my YouTube playlist, if you will be able to observe, in FANG interview series, I have already talked about this algorithm in the linked list cycle part. Yes, this is the same algorithm which will be working here as well, but with different set of approach, but with different set of mindset. So in this upcoming recording which I am attaching for the paid course, you will be able to observe, I am discussing with my students that how basically we can solve this question. This recording is available, why I am sharing with you all, because this question is usually asked. Might be you will not able to take the course because of some money constraints. So I think knowledge is something which is because you don't have any money, you will not able to afford that. I think that is not the limitation nowadays. So that's where I am uploading that video on the YouTube for free, so that those who are not able to enjoy my paid courses, they will be able to enjoy this free content. Please make sure that you will subscribe to the channel, and you will try to share this video as much as you can if you find the content insightful. And I believe this particular approach will help you out in a lot many interview problems. Lot many interviewers usually ask this kind of a problem because they know that many people are not aware about this fact. So without wasting any time, let's get started. This is the nums array we have, which is 1, 3, 4, 2, and 2, right? List that we have. So the index number is 0, 1, 2, 3, and 4. What I will do is, I'll try to create, first of all, a structure of this particular list available to me. What we will do is, we will try to observe one important thing is that, whatever be the value which is available inside this list, we always have an index number available for that. Can I say this thing? I will be having a list of numbers, which is 1, 3, 4, 2, and 2. 0, 1, 2, 3, 4. Number of elements I have is 5. What I'm saying is, as per the explanation given to us by the LeetCode platform, can I say that whatever elements which is available inside this particular list, because there is always one element which is repeating, apart from that, all other elements will be only occur one time. So can I say that the elements which are available inside this list, I will be having an index number for that? For example, the number which is available at 0th index is 1. 1. I am trying to create a node corresponding to this number. Go to index number 1. What is the next value? It is 3. So 1 is pointing to the next number 3. Go to the third index. What is that value? 2. Go to the second index. What is the value? 4. So 2 is pointing to 4. Go to fourth index. Fourth index is pointing to 2. Can you see how I designed this structure? What I have done is, I started exploring from the very first index number, which is 0, 1, 1. Go to index number 1, what is the value? 3. Go to index number 3, what is the value? 2. Go to index number 2, what is the value? 4. Go to index number 4, what is the value? 2. Now, because if you will be able to see by scanning this entire particular list, with respect to this 2, there are 2 pointers pointing to this node number 2. That's why, can I say this is a duplicate node? This is a duplicate number. In a layman term, try to understand how we can do the implementation. I'll show you. Don't worry. As of now, just try to get my point what I'm trying to convey here. There is only a single node for which there is 2 references pointing, apart from the complete structure that we have. Can you observe? So obviously it means
can you
that 4
please
is also
repeat this
pointing to 2
diagram?
and 3 is also pointing to 2. That's why it's a duplicate number. Yes, Prajwal.
Can you please repeat this diagram? I was confused.
So here, at 0 index, we will be having a value 1, right? So we have a value 1 at 0 index. Go to whatever the element given to you, go to that index number. Go to index number 1. What is the value next? 3. So 3 is available. Go to index number 3. What is the value? 2. 2 is available. Go to index number 2. What is the value? 4 is available. So 2 is pointing to 4. Go to index number 4. What is the value? Again 2. Again 2. So what you are observing is that 4 is also pointing to 2 and 3 is also pointing to 2. That's why it's a duplicate element. Is this understanding or intuition is clear?
Priya, just I wanted to take one short example with the nums array.
Okay.
Replace 1, 2 with 5. one of the
Let's
two,
take
it's
one
fine.
more array. You will tell me what is that array. Let me take it on a different page.
Yeah.
Yeah.
So take 5, 4, 3, 2, 1.
5, 4, 3, 2, 1. Then what is the repeated
That's it.
here?
There is no repetition.
That is not there, no?
Okay, got it. My mistake.
Okay. They have already mentioned that compulsory you will be having one element which is repeated. So this is not the case which will be possible. This is not a test case. Okay. Is so far so good? Shall we move ahead? Now, in this case, what I can do is I'll try to create 2 pointers. This algorithm is famous by the name of the theory of hair tortoise, or by the name of fast and slow pointer. Anything you can name it. Few days back only I have talked about 2 pointers approach. This is also a variety of a 2 pointer approach, where you are saying that you will be having a fast pointer which will move 2 steps at a time, and then you will be having a slow pointer which will move only 1 step at a time. Or you can have a tortoise which will move very, very slowly, act as a slow pointer. You will be having a hare which will move very fastly, act as a fast pointer. Initially, they both are pointing to the 1. So we will be having a slow pointer. We will be having a fast pointer. Both are pointing to the value 1. Now, what I'm saying is, slow pointer, only 1 movement. Fast pointer, 2 movements at a time. At any point of time, when they will meet, that is the intersection. That is the intersection of both of them. So let's see where they will meet. Let's run slow pointer 1 step. Where it will go? If I run this slow pointer 1 step?
3.
3. Please pay attention. Otherwise, you will miss the class. You will miss this particular point. Where will be the fast pointer?
2.
It will point to 2. Okay. In the next iteration, where will be the slow pointer pointing to?
2.
2.
Where will be the fast pointer pointing to?
2.
Same 2.
Same 2?
Yes.
Because 2 steps you have to move. Can I say, everyone? It means this is the intersection
Correct.
point.
Yes.
This is the intersection point. It can be some other point also. It's not that it is always that duplicate number only. But now, second part of this algorithm says that what you will do now, when you will be able to get both of them meeting point, this is the meeting point, intersection point, or meeting point, you can say. Now, what you're supposed to do, again, take your slow pointer from the starting position. Switch your slow pointer. Once you will be able to get that meeting point, hold the fast pointer there only, and start initialization of slow pointer again with respect to the very first node, 0th, at nums of 0, whatever element is available. Now again, do same thing. But at this point of time, both of the pointer move 1 step at a time. And it will move until they both will not meet to a same point. So now, move only 1 step, both of them. So slow pointer will point to 3. And fast pointer will point to only 1 step you have to move.
4.
4. Again, they're not meeting. Go ahead. Slow pointer will point to, next case,
2.
2, and fast pointer will point to
2.
2. This is the point which you will say is a duplicate point, duplicate number. So there are 2 phases of this algorithm, what I said. In first phase, you will be finding out a meeting point of both the pointers. meeting point of both the pointers. How will you able to find out? Just now I have talked about that you will try to see that at any point of time when they both are meeting, tortoise and hare or slow or fast pointer, you will break that part. After that, in the second point, what you will do? You will find out what is the starting entrance of the cycle, from where the cycle is started. Coincidentally, in this example, our cycle started from this 2 itself. That's why you will observe that both of the points meeting at this 2. Meeting point or intersection point is also at 2. Entrance is also at 2. So where is the entrance of the cycle is where we will be having a duplicate number. I will take some other example and then again we will discuss the same thing, because here 2 is coming up. It might confuse you. Let's take this example and then we will again see. This array we have. So in this case, let's try to design this. 3 is there, 1 is there, 3 is there, 4 is there, 2 is there. 0, 1, 2, 3, and 4. Number of elements we have is 5, right? Let's design this. So we will be having 3. Go to index number 3, pointing to 4. Go to index number 4, pointing to 2. Go to index number 2, pointing to again 3. Go to index number 3, pointing to again 4. 4 to, I think this is the structure which keeps on going, if I'm not wrong. 3, go to 3, it is 4. 4, go to 4, it is 2. 2, go to 2, it is 3. Cycle is there. Is this clear? This particular diagram is clear, everyone? Is it correct or not? Now it means that we have to start looking upon that, slow and fast pointer. Initially, both of them will be pointing here itself. Slow will be here, fast will be here. First iteration, where the slow will go? At element number?
4.
4. Where the fast will go?
2.
At element number?
Third element.
2. Can I say? Slow will be here, fast will be here. They are not meeting yet. Again, next iteration, slow will go where?
2,
Fast will go where?
4.
4.
So you are saying slow will be at 2, fast will be at 4. Next iteration, slow will go where?
2, 3,
3.
Fast will go where?
3.
So basically, what you can do, you are saying that slow will be also here, fast will also be here. And because now both are equal, you will stop at this point of time. You will break at this point of time. Now you need to find out, this is the meeting point. This is the intersection point where your values are intersecting. But you are saying that this is the point where you have some cycle. But now from where the cycle is started, that is what we have to find out. For that, fast pointer will remain at same position. Slow pointer will be at nums of 0, which is 3 only. So in this case, again, coincidentally, they are at both the same locations. So automatically it will say that 3 is the duplicate number. And it will return that. So can you able to understand this point, that basically how the duplicacy is happening, how we will be able to get the duplicate number in this particular entire structure? Always remember, if you are saying that you are having a duplicate numbers, you will saying that cycle is there. Cycle is there in my list. And this is how the cycle will be created. This is the meaning of a cycle, that you are starting from somewhere and again you're going back to that particular number again. So what in a way we have done in this case to find a duplicate, there are 2 components I have talked about. I have taken slow pointer and I have taken a fast pointer. Both of them initially are starting from nums of 0, which is the very first element. For example, in this case, if you will be able to observe, we have started with a 1. We have taken our value of slow is also 1, fast is also 1. It is available at nums of 0. Now, you are doing a movement of slow by 1 step, fast by 2 step. Means in first iteration, you want your slow pointer to move to 3 and your fast pointer to move to 2. Am I saying it correctly? In the very first iteration, how you will get this number? Via code part implementation, you are saying, I will keep on moving this particular thing while my condition will get true. My slow pointer is nothing but is equals to nums of what? Check it out. Your slow
Plus
pointer
1.
will be nums of
Plus 1.
how this
Of
3 is
slow,
coming
right?
up. How is this 3 coming up? Can I say
Nums
that
of
the
slow.
index of the
Index,
slow pointer?
Yes.
Nums of slow. Can I say, everyone? Don't get confused. How this fast pointer 2 value is coming up? How is this fast pointer 2 value is coming up? Can I say it will be nums of fast? Check.
Yeah. But Priya, when we are initializing it, should we be initializing it as nums 0 or just 0?
Nums 0, right?
Nums
Because
0. Okay.
initially our both values are at this point. Then we are moving 1 step slow, 2 step fast. So in terms of implementation, 1 step slow means you are saying nums of slow. Initially nums of slow will be nums of 1, which will be 3. Now you want that fast pointer to be there at nums of 3, which is 2. So how will you get that? Nums of fast. Is this correct, everyone? Can you guys give me a confirmation until so far?
Could you please
Yes.
repeat?
How this 2 is coming up? Check it out. I want my fast pointer to reach to 2. Yes or no? I want my fast pointer to reach to 2 steps at a time. So how this 2 is coming up? Where is your fast pointer as of now? 1, right? So you are saying nums of fast. Nums of fast. So what you will be able to get as an answer? Nums of 1, which is 3. But you don't want to go to 3. You want to go to 2. So you will take a further index of this number, which is nums of 3, which is 2. So you will be able to get this value. It means now you move 2 steps at a time. In this way, you move 2 steps at a time with respect to fast pointer. Is this correct now? Okay. What I have said, intersection point we have to find out, meeting point. How we will be able to get? If my slow and fast met at any point of time, what I told you, I will stop there. I will stop there, means break. This is the part 1 of our implementation, where what we have done is, until so far, we have find the meeting point where the 2 pointers are meeting of the 2 pointers, which is slow and fast. Yes. At this point of time, after this while loop, I am very much sure that I will be able to get both of them at one place. Yes or no? Part 2 of this code is to get the entrance of the cycle. We need to find the starting point, or you can say the entrance of the cycle, which is there. And that would be the duplicate element that you really want to print. So what you will do, you will initialize your slow pointer with nums of 0 again. So it will start from a scratch, but as of now, your fast pointer will be at its previous location only, where that was available. You will say until my slow pointer is not equal to the fast pointer, I will move 1 step at a time. Both of the pointers now will move only 1 step at a time, meaning your slow will become nums of slow, and your fast will become nums of fast. Both are moving at its own pace, only one step at a time. At any point of time, when I will move out of this while loop, what does that indicate? That now they both met. When they both met, I'll return the position of, let's say, fast value. So basically what will happen? This number, this fast number will indicate you the duplicate number value. That is the only thing which we're supposed to do. Let's try to run this code. We'll see if we get some issue. So 13422, 2 is the thing which we are getting here. Working fine. So basically, now just again look upon this, what we have done. Two parts. First part is to get the meeting point. How we will be able to get? By moving slow pointer one step at a time, by moving fast pointer two steps at a time. When they both meet, that is the intersection or the meeting point. Second thing, we need to make sure that what is the entrance of the cycle. Okay, we got the cycle, that there is a cycle existing, but from where it started, that is the point which is the duplicate number. For that, what we have to do, we started with a slow pointer at the very start, nums of 0. Until my slow is not equal to fast, I will move slow pointer with one step, fast pointer with one step. When they both met, that is the location which is the duplicate number I will be able to get. In that case, I'll return my value. This is the concept behind the Floyd's cycle detection algorithm. We will do the similar kind of a question in a linked list. Very, very famous, very widely asked in interviews. Many people are aware in duplicate numbers, the approach of a dictionary one, where we will be having a space complexity of big O of n. But there are very few people who are aware of this approach. So what makes you unique from them is this approach. You will be able to observe in this approach, the time complexity, if I'll ask you, what do you think? What is the time complexity?
Order of n.
Big of n.
What is the space complexity?
Order of one constant.
Or
And that is what we want, I think. Just give me a second. Yeah, is this fine? Any doubt? Shall we look mathematically how it is working, algorithm? How researchers develop this algorithm mathematically? Do you want to have a look or shall we move ahead?
yes.
See, let's take some big example because the test case which they have provided is very, very small in even both the test cases. Maybe I will be having a number which is, let's say 0 node. After that, we will be having 1. Then let's say we will be having 2. Then let's say we will be having 3. Then let's say we will be having 4. Then we will be having 5. And then let's say we will be having again cycle pointing to 1. Now, if I'll ask you what is the duplicate element in this particular entire cycle, what will be your answer?
1.
1.
Very good. How you get that 1? Because you will observe that there are 2 pointers pointing to the same node, which is 1. This is a big example which we can talk about. Let's take the same approach here again. So what we have said just now is we will start the slow and fast from the starting. First phase is to get that meeting point where both pointers are meeting. Let's move slow pointer 1 step. Slow will be here. Where is the fast pointer? 2
At 2.
steps at 2. Next iteration, where will be the slow? And where will be the fast?
Slow will be at 2
Slow is at
and fast
2
will be at
and
4.
fast is at 3. At
No. Yeah, fast will be at 4, I
4.
think,
4.
right? Because I removed early. Okay, perfect. Now, where will be the slow? Where will be the fast?
slow is at 3 and
Yeah,
fast
fine.
is at 1.
Very good. Perfect. Let me erase this thing. Next iteration. Where will be the slow?
Slow will
is
be
at
at 4 and fast will be at
fast
3.
will be at 3.
Okay. Let's move ahead. Next iteration.
Slow will be at
Slow
5
is at 5 and fast
and
is also
fast
at
will
5.
be at 5.
That's a good example. That's what I was about to pick, but I didn't get from lead code. This is a good example, actually. Listen this very carefully. See, that's what I was talking about initially. I don't know how many of you got my point at that point of time, but this is a superb example which you got unintentionally. So here, if you will be able to see, this is not a duplicate number, but as of now, we got the meeting point where both the pointers are meeting. But I don't know from where the cycle begins. I want to get the entrance of the cycle. That is where my duplicate number lies. 5 is not my duplicate number, 1 is my duplicate number. Now what I will do? I will put my fast pointer as it is, but I'll change the location of this slow pointer starting from again 0. That's what I did in the second phase too. Have you remembered that? The code part? Now again, we move
Yes.
one step at a time until both of them will meet. So now where is my slow pointer and where is my fast pointer in the next case?
Both pointers
Both are
will be
at
at
1.
1.
Yes, that is what I want to refer at that point of time. Now, if you will be able to observe, I will be able to get my slow and fast at same location. And this is the indication that it's an entrance point. So now what I will return is the fast value, which is 1. Now, is this clear? I think this example gives you a better idea about what is happening. Part 1, what that is doing. Part 2, what that is doing. So basically, if you will be able to observe, let's say the difference between this meeting point and this duplicate number is x. Okay? And let's say this complete cycle scanning is C. Let's say this complete cycle scanning is C. Okay? C minus x. This complete is a cycle. This complete loop is a cycle. Or maybe I'll represent by this. This complete is a cycle, C. And in this cycle, this part is x. So the remaining portion is C minus x. Okay. And I don't know what happened. So here, the difference between these two values from 0 to 1 is, let's say, P. Okay. Now, if you will be able to observe, my slow pointer is moving 2 times slow is nothing but is the fast pointer, because we are moving fast pointer 2 steps at a time, slow pointer 1 step at a time. So this equation will hold true. Now the question is, how much your fast pointer will move? So it will be this P plus my fast pointer will move complete cycle C plus it will move until 5, C minus x. So what is happening is, my fast pointer is moving this P plus might be 1 cycle it is finished completely plus C minus x, and that's where it will be able to get this value as 5. But my slow pointer will move how much? It will be P plus c minus x, because my slow pointer just went p and then just went till 5 and we'll be able to get that 5. But until that point of time, my fast pointer will be p plus complete cycle it iterated plus c minus x, and that's where 5 again they met. That's where they both get intersected. So if you will be able to observe it, this is what is happening. My fast pointer is moving 2 steps at a time, and that's why already my fast pointer covered one complete cycle plus then c minus x, means at 5 they both met. If you will solve this equation, what you will be able to see, 2p plus 2c minus 2x is equal to p plus 2c minus x. Cancel out. P is equal to x. This is what you will be able to get. So what is the meaning of this? This distance you will be able to get is equal to this particular point. Means at any point of time when they both are meeting this value of p and x, that is the entrance point, entry point, and that is where you are saying that you will be able to get that duplicate value. And that's why you are just doing the second phase, where what you are saying that until my fast and slow will become equal, you're starting from a scratch, and then one step at a time, you're just trying to remove this gap of p and x. At any point of time when they both will get equal, that is the duplicate point which you have to print, duplicate number that you have to print. That's the entrance point when they both are equal to each other. So this is the overall idea about the algorithm also. If it is not clear, that is also fine. Maybe you can have a look more into this equation. You will be able to get my point, what I'm trying to convey here. But getting this algorithm intuition, I think this example will help you out with respect to how we will be able to get the duplicate number. How in the first phase we're getting a meeting point, and how in the second phase we're getting the entrance or the starting point of my cycle, which is 1, meeting point was 5. It is different in this case. In the above cases, the number was same. So that might be confusing to you, but I think now it is appropriately fine for everyone. Still, if you have any confusion, please do ask from me. Otherwise, we can move ahead.
Priya, just wanted to ask one thing, that in the second phase, fast will move also one step at a time, right? Just as slow.
In the second phase, both will move one step at a time.
Okay.
Okay. In the code also, you can just verify. Right? Both are moving one step at a time from its own location. Perfect. Shall we move ahead? So this is the optimized approach as comparable to whatever approaches we have discussed so far. Next important part is the part of recursion, which I really won't talk about in today's session. We'll talk a brief overview of that, and I will wrap up afterwards. Might be you guys feel boring, or it is interesting till so far.
Oh, it's very interesting.
It's interesting. How many of you feel interesting?
It is interesting.
Yes, it's interesting.
Interesting and a lot to process. A lot to process. That is true. There is a lot more things in DSA. That's what I'm saying. DSA is a very vast thing. The more we deep dive into logics, the better understanding we will be able to develop, right? It's a very vast subject. And
Yep.
if
Priya,
for one question also, we can spend 5 hours. If you will say that today we have to just do only single question, Priya, and can we sit today? I can spend 5 hours also in that question. This kind of vastness one question contains. As of now, there are a lot many things, I think, that also I'm trying to skip so that we can move to the next topic. Otherwise, we can spend one day, one question also. That is the vastness of this topic's all about. Right? So please do spend your own time after the sessions. I can't take 24-hour session with you all. I can take only 2-3 hour session. I really want you all to, deep dive into this subject and experience the interesting things that we have in this subject, right? Recursion is again a very, very interesting topic. And you will love it. If you understand it, you will love it. If you will not understand it, you will be like that, why this recursion is there in the DSA. You will always say bad things to this recursion. But let me tell you, this is, the heartbeat of DSA. If anyone is not aware about this concept and he says that, oh, I can do everything in DSA apart from recursion, understand that he don't know DSA. Because if this topic anyone is not aware about or is not having a good expertise over, then maybe he or she is good in maths, maybe he or she is good in logics, but they are not good in terms of implementation of those logics. And that's where again you find a difference. So please try to understand this topic also very well. And today I'll give you a brief overview. I don't want to be very much heavier portion with respect to recursion part, because already we have used our brains a lot in the entire session, right? We are discussing interview questions only from the very starting. So we will take it very, very easy questions as of now. And from the next class, I'll take a bit complex questions of interviews with respect to this recursion. Very important concept. What is this recursion all about? As the name itself suggests, recursion. When we call in our function definition, when a function call itself, when a function call itself, that is something you can say it as a recursion. For a very simple example, if I'll provide you, let's take an example of a factorial of a given number. Factorial of a number. So let's say we will try to find out a factorial of 5. I hope everyone knows what is the factorial of 5. It will be
120.
5 into 4 factorial.
5 into 4 factorial, 4 into 3 into 2 into 1.
1.
Layman terms, you will say it will be 120. That's how we calculate this, right? Okay. Now, this can be written as the Pawan said, I think 5 into 4 factorial. And this 4 factorial can be written as 4 into 3 factorial. This is 3 into 2 factorial, 2 into 1 factorial. And what is the factorial of 1? It will be, what is the factorial of 0? And what is the factorial of 1?
1.
Both 1.
Both are 1. Some people say factorial of 0 is 0, which is not true. Okay. So whenever we're talking about a recursion, always in a recursive code, think about two things. First thing is the base case condition. What is the meaning of base case condition? The simple meaning is that when your value of n is very, very small, can you directly return the answer? When your value of n is very, very small, can you, without doing any calculation, return the answer? And second thing is recursive function call. Recursive function call. Base case condition and recursive function call. For example, for the same problem, if I'll ask you, what is the code to write a factorial of n? The code will be, you will say, what is the base case condition? Now you will think, for which value of n, I can directly return the answer. For which value of n, I can directly return my answer.
For
0.
0 and 1.
Yes, if the value of n is either 0, or you can say if the value of n is less than or equal
2.
to 1. Considering we will be having a value more than 0. So in that case, directly we can return the answer as 1. Else. This is the important point. Otherwise, my factorial will be what? What I can return as an answer is, can I say n into fact of n minus 1? Can I say everyone? It will be
Yes.
n into fact of n minus 1. Because at each and every point of time, what we are trying to do here is, we are trying to reduce our number by 1 by 1 by 1 by 1 and so on. So here, if you will be able to observe, if you will try to implement this particular pseudocode, what you will be able to do, let's try to find out what is the value of factor of 5 again. So you will say, my value of n is not less than equal to 1. So what I will return is 5 into factor of 4. Right? Again, my value of 4 is not less than equals to 1. I will return 4 into fact of 3. Again, my value of n is not less than equals to 1. It will be 3 into fact of 2. Again, it will be 2 into fact of 1. And this is the point where I reach my base case condition. The answer will be 1. So now the answer will be 2. 3 into 2 is 6. 6 into 4 is 24. 24 into 5 is 120. And that is where I will be able to get the answer. So in a way, the base case condition is nothing but is a stopping condition where my code will get stopped. And if you will not write a stopping condition or a base case condition in any recursive code, you will be writing or you will be violating a property of algorithm. What was that property? Your code will keep on iterating infinite times, right? Which is not a valid algorithm. Very first class, if you remember. So always remember, in a recursive code, we always have to write a base case condition, which will stop our code at any point of time. For example, here my condition met and then I'll go back, right? And getting the answer as 120. Now, is this clear so far, so good? If you will be able to observe, this is my method name. This is my method name. And if you will be able to observe, I'm calling the same method inside this fact. Same method or function name, but different parameter. Right? Method name is same, but the parameter inside this fact is different, which is n minus 1 at every point of time. And this is why it is called as a recursion. This is the overall concept of recursion. First thing is base case condition. In every code you will find out. Second thing is the recursive function call. Recursive function call, which you will be able to find out. Two components always you will be able to observe. So far, so good. Shall we move ahead? Okay. Now you can ask me one question that, Priya, how my code will get to know that, okay, once I will be able to get the answer of fact of 1 as 1, I have to go back to fact of 2. Then I have to go back to fact of 3. Then I have to go back to fact of 4. Then I have to go back to fact of 5. Any idea? Because does my computer system have some memory? Somewhere it is storing these function calls. What is happening internally?
Stack. Recursive
That's
stack.
where the concept of stack-based data structure came into picture. What is stack? Stack is a data structure which implements a LIFO kind of implementation. Last in, first out. So whichever function call will go at the very last, that will come at the very first. So what is happening is that all these function calls which we are doing, they are stored in a stack-based data structure. So what is happening is fact of 5 will be stored first. Then fact of 5 is calling fact of 4. Then fact of 4 is calling fact of 3. Fact of 3 is calling fact of 2. Fact of 2 is calling fact of 1. And now my fact of 1 is returning the answer as 1. And then the function call will go back to fact of 2. Here, can you see? Last function call which I have inserted in this stack is fact of 1, which went very first out. Then fact of 2 was called. Then fact of 3. Then fact of 4. Then fact of 5. At the very end, you will return the output. So always remember, in a recursive call, at the very end, when you're saying that your code is printing some output, it means your stack is empty now, because all the function calls is terminated. Then only you will be able to get the final result, final output. So in this case, always remember that there is a point to note here. For every recursive code, we always require stack-based data structure to store the function calls. For every recursive code, we are using a stack data structure to store the function calls. Always. It means that we are somehow using a space complexity here. So if I'll ask you in this particular code, what is my space complexity? I'll talk about time complexity part within a few minutes. But if I'll ask you what is the space complexity, what will be your answer?
Order
Constant.
of n.
It's not constant. Just now
It's order of n.
Yeah, for every data structure, for every recursive code, we are using a stack data structure. Any external data structure we are using to implement our code to get the answer. And here, if you will be able to observe, when the value of n is 5, how many levels of stack I'm using? 1, 2, 3, 4, 5. Can you see? 5 spaces I'm using here. When my value of n is 5. When the value of n is 10, for example, I am trying to calculate factorial of 10. I will use a 10 level stack space. So it means that the space complexity of this code will be big O of n because of the usage of this data structure, which is stack, which always be the used one in a recursion. Let's talk about the time complexity. Let's take that T of n is the time complexity of this code, fact of n. For the base case condition, first component, what do you think is the time complexity?
O of 1.
It is constant C.
Constant. Hmm.
When your function is repeating, which is T, fact of n, it is repeating again here, but the parameter is n minus 1. So you are saying it will be T of n minus 1. It is again available inside my function call in the else part. Into n you are doing multiplication task you are doing, which is a constant task. For example, here you are saying 5 into 24 or 4 into 6 or 3 into 2 or 2 into 1. This multiplication task is a constant task. But the important factor is this, that how many times you are repeating this function call. And that you are taking care of this term of T of n minus 1. So what you are saying, this is something which we call as a recurrence relation, which I will have to talk about in a very detail in the upcoming sessions. So today we're talking in a very lot more brief context. What is the recurrence relation? For every recursive code, in order to find out the complexity, time complexity, first of all, you need to compute what is the recurrence relation of that particular code. How will you evaluate that? Just now I have shown you. So what you have said in the factorial of a given number code, that T of n, when my value of n is less than equal to 1, when my value of n is small, it is either 0 or 1. In that case, it's a constant because it's a base case condition just now we have discussed. But when the value of n is bigger than 1, then it will be T of n minus 1 plus C. Plus C is a constant task for the multiplication part that we are doing further. But T of n minus 1 is what? The repetition part. Because it's a recursion, it indicates that the function is repeating. T is repeating. But with different set of parameters. What are the parameters? N as n minus 1 at every step. Until I reach to this base case condition, when my value of n is less than equals to 1. Now to solve this recurrence relation, we have 3 methods. One is substitution method. Second one is we have recursive tree method. And the third one is what we have is master's theorem. Master's theorem. You can apply any of these methods to get your time complexity part in terms of big O. Directly, you can't compute. So what is the substitution method? I will today talk about this. How can we get this time complexity with the help of the substitution method? Further, we will talk in future sessions, okay? So what we are saying, T of n is equals to T of n minus 1 plus C. Solve this case. When I'm saying substitution, substitute this equation of T of n minus 1. What is the equation of T of n minus 1? This is the standard equation, right? Just replace this n with n minus 1 everywhere. So what is the value you will be able to get with respect to this T of n minus 1?
T of n minus 2 plus C.
Very good. Very simple thing you have to do. Substitute this n with n minus 1 everywhere. So n will be replaced with n minus 1. So can I say it will be n minus 2 plus C? Yes or no? So if I just replace this equation here, I will be able to get the equation as T of n minus 2 plus C. Already plus C is available. So it will be 2C. Can I say everyone?
Yes.
This is the second equation we will be able to get. This is the first equation we got as a recurrence relation. If I'll say, again, substitute the value of T of n minus 2, what you will be able to get? The T of n equation. Can I say it will be T of n minus 3 plus 3C? Third equation. Now, how many times I will repeat this task? Let's say I will repeat this task k times. So for the kth equation, what is that equation I will be able to get? T of n is equals to, can I say T of n minus k plus kc? Because for the first time, this was the equation, generalized equation. For the second time, this 2 and 2 is there. For the third time, this 3 and 3 is there. So if I'll do this k time, can I say this k and k will be the generalized equation? What I want internally this number to be? I want this number to be equal to 1 because I just know the value of T of 1 as 1. If someone will say what is the value of T of 1, I will say the answer will be 1. It's a constant task. Can I say everyone? Just now we have discussed, it's a constant task. So if I replace this value of n minus k equals to 1, what is the value of k? It will be n minus 1. Can I say everyone? So if I'll replace this value of k with n minus 1, what is the equation I will be able to get? n minus 1 plus n minus 1 into c. So it will be T of 1 plus nc minus c. This value is nothing but is a constant or 1 or constant you can say plus nc minus c. This will be replaced. What is the complexity? Big O of n. This is the overall time complexity of your factorial code. Substitution method. Why it is called substitution method? Because here we are doing a substitution of the recursive term until k times. Then we try to compute the value of k. We'll try to substitute that value and finally we get the final answer as the time complexity of that particular code. Is this clear to everyone?
Why we are taking k equals to n minus 1?
We are taking the value of n minus k as 1. Why we are taking n minus k as 1? Because we just know the solution of this one only. It's a base case condition. We know that when the value of n is 1, the answer will be 1. You know, no? When the value of 1 factorial is 1. It's a constant task. It's 1. That's why when you compute the value of k, it will come out to be n minus 1. And then you replace that value of k with n minus 1 in the complete equation. So it means that in this case, in this code, we will be having a time complexity as big O of n, as well as the space complexity is also big O of n. The next problem is about the Fibonacci series. And with the help of this example, we will understand the second way of solving a recurrence relation, which is the recursive tree method. I'll not go in very detail of this. We will wrap up the session very soon now. Fibonacci series is what? Anyone who is aware about this series, I'll give you this as an assignment prior to your home, the implementation of both the codes, factorial as well, Fibonacci also. Okay.
Addition
0,
of two
1,
continuous
1,
numbers
2.
will be the
Exactly.
next number.
So here, if you will be able to observe, you only tell me that, how we will write the code for this. So here we will be having 1, 1, 2, 3, 5, 8, and so on. 0, 1, 2, 3, 4, 5. So if let's say someone will say, what is the value of fib of 5? Your answer should be 8, right? This is the kind of a output I'm looking for. So how we can solve this problem? Can you tell me recursively what is the base case condition and what is the recursive code you will write here?
If n is 1 or 2, we return. Sorry, go ahead.
If the
N is 1 or 2, we'll return. So in this, okay, you are doing it to 0 index. So if n is 0 or 1, then we'll return 1.
yes, if the value
That's the
of n
base
is less
case.
than equals to 1, we can return the answer as 1. Else, what we can do? We can return.
We need yeah. So we'll return fib of n minus 1 plus n minus 2.
Very good. We can return the value of fib of n minus 1 plus fib of n minus 2. Is this correct, everyone? Do you guys agree with me? For example, just now I have said fib of 5, right? Let's take this example. Let's try run this part. We are saying fib of 5, right? It's not less than equal to 1. So we are saying what I will do, I will calculate what is fib of 4 plus I will calculate what is fib of 3. Yes? Again, what I will do, I will calculate what is fib of 3 plus what is fib of 2. Again, I will calculate what is fib of 2 plus what is fib of 1. Again, I will calculate what is fib of 1 plus what is fib of 0. Yes or no, everyone? Yes? Now we know this answer is 1. This answer is 1. So this answer will become 2. This answer is 1. So again, this will be 3. Fib of 2, I have just now calculated, so I will not repeat the recursive tree again. I'm just directly writing it down as 2. Just now we have done, so it will be 5. Fib of 3, just now we have done 3, so it will be 8. So we will be able to get the answer as 8. Is this correct?
Yes.
Make sure I have not repeated the implementation of this recursive tree, but it is there in the code, in the broadening part. Now, this is the major issue in recursion actually, which we will come up in a later part where DP came to rescue this recursion. If you will be able to observe, fib of 2 we have already calculated on the left side, right? But again, I am doing a calculation on the right side. I just copied it down, but this is not how system will work. System will do the recalculation. There will be a recomputation of similar function calls which will happen. There will be a recomputation of similar function calls which will happen. And that is the major issue. That's why you will observe that in this particular code of recursion, it is having an exponential time complexity, which we will talk about. When I was talking about the exponential time complexity in the complexity class, class, so someone told me that, can you give an example of exponential time complexity? I don't know who was the one, but now you will observe that this is the case where we will get this very, very huge time complexity. And that's why your test cases will not get passed. Again, this problem is available on LeetCode. Just check it out after the class, the problem of Fibonacci series. There is two problems
Yes.
actually. One is Fibonacci
So
series and another one is climbing stairs. I will also upload the problems in the, I didn't get the time today, but I'll upload it very soon. All these problems which I'm side by side covering up in the classes. So you can just check it out. But as of now, I have mentioned these problems. Look upon that. You will observe in lead code, there is one problem where they are taking a very small number. You can explore or I will let you know. So just explore, okay? There is one problem where you will see in the constraints, they're taking a very small number for which this recursive function call will work. But for one of the problem, this will not work.
only 45.
This is not only for recursion.
Is it like
Uh,
this exponential? Is it like 2 to the or something? Because that's what it seems to be.
C की power n, 2 की power n. Do you remember the last, I think 7th number class, which we have just talked about in our complexity class, which is C की power when I talked with you. So it's 2 की power n is the exponential one. Okay. So here you will observe that in the Fibonacci question, they are taking a range of the value from 0 to 30. For this particular question, the code of recursion will work fine because it's a very small number. But after 30, they're taking until 45. That's where you will get an error of time limit exceeded, TLE. Try to solve both of the problems after the session. Both problems you can solve very easily. Okay? But you will observe that the problem of this recomputation of similar function calls is very major issue. When you will be having a very small value of n, it will be fine. Recomputation will be done and you will be able to get the answer. But consider that you will be having a very big value of n. Okay? At that point of time, your tree will be bigger. You will be having more recomputations again and again of similar function calls. That will waste more time and that will cause a time limit exceeded issue, which is in a climbing stairs problem. Because there they are taking a value until 45. Here you will not face because there they are taking a value until 30 only. So that is the issue. Here, how this complexity will come out to be big of 2 की power n. We will solve it in the next class via the recursive tree approach. Today, I'll not solve that because it's again a complicated approach. And I don't think it's you are having a very fresh mind to again recap these things, recursive tree approach. We will discuss this with a very fresh mind and then we will see that how this I'm saying as a exponential one. But as of now, you can consider that it's a very big time complexity. And the major reason for that is this only, because here it is doing a recomputation of similar function calls. This is also called as a problem of overlapping subproblem. There are subproblems which are overlapping and we are trying to recompute those overlapping subproblems, which causes this complexity to be very, very high. And in order to get rid of this problem, there comes an existence of dynamic programming. So in any problem where this is a common issue, overlapping subproblem, DP is the only solution to resolve this issue. So we will in future talk about this DP also in a very detail, but as of now, I think logically you can think about this perspective. If I'll ask you, what is the recurrence relation of this code? Anyone who can tell me? Just the creation of recurrence relation. We will solve it in a later session, but what is the recurrence relation of this particular code?
n minus 1 plus n minus 2.
Very good. So here, the recurrence relation will be when the value of n is less than equals to 1, it's a constant again. It will be 1 only, right? We are returning the answer as 1. If the value of n is bigger than 1, in that case, can I say it will be t of n minus 1 plus t of n minus 2 plus c, constant task for the addition part, right? We are doing at the very end addition also of the numbers which we're getting. For example, in this case, 1 and 1, then we're doing addition. 1 plus 1 is 2. So it's a constant task which we are doing further. So can I say this is the recurrence relation of this particular code? And then we have to solve this recurrence relation. Always remember, when you will be having more than one recursive term, for example, in this case, you have two recursive terms. The only way to solve this recurrence relation is via this recursive tree approach only. You can't solve this via substitution method or Master's theorem. You can only solve this particular recurrence relation by a recursive tree approach. How it can be solved, we will discuss in the next class. We will start our session from this only. T of n is equals to T of n minus 1 plus T of n minus 2 plus C. How we can solve this, and we'll be able to compute the complexity as exponential. But is this clear? I think now we can wrap up the class. Until so far, I'll not discuss further new concepts now. I think it's too much as of now to take it. Whatever things I have discussed, I'll share the notes again. Please go check it out. Everything, whatever interview questions, concepts we have discussed, algorithmically, things we have discussed. What is recursion we have discussed. Try to implement the problem of Fibonacci climbing stairs. And the third one is factorial of a given number. I have given you the pseudocode, but I think I didn't show you the implementation, right? So recursively, how we can solve these problems, right? Implementation. These two problems you can implement on a lead code platform directly. You will get an issue in this case, TLE issue. That's completely fine, but implement this, both of them. And this problem maybe you can implement on a Google Colab. And check it out that whether you are getting a correct answer of the factorial of a given number or not with respect to whatever approach we have discussed. Is this fine? This is the assignment. And if you face any trouble, do let me know in the discussion part. Please discuss with your colleagues also. Help them out, right? If let's say someone is able to get the code pretty well, help the other person out with respect to the code implementation part. So now if you are still here, I believe that you really like the session and you will be able to get the approach as well. If still you feel like that there is a need for you to join the session, which is live sessions which is going on, you can still join. It's just 1 week have passed. All the recordings of the paid courses are still available for each and every one to just rewind whatever things we have covered up, and whatever doubts let's say you are having in the previous week where you were not there, I will be open to take that as an extra session to resolve those doubts as well. So please to check it out. The course link is in the description of this video. And with this, bye bye everyone, and happy learning to all.